Singapore is a respected regional semiconductor hub. There are hundreds of companies in the semiconductor industry in the country, making up 11% of global market share. The semiconductor and electronics industry forms about 40% of Singapore's economy. The sector has been expanding year on year, with demand driven by new applications and technologies. Indeed, the manufacturing of this tiny chip is supported by a rich ecosystem consisting of multinational companies as well as local small and medium enterprises. Building semiconductors is a complicated process of R&D, manufacturing, testing, packaging, quality control, distribution, and marketing. The entire chain can be divided into 8 categories. Companies in this category design products and subcontract the manufacturing process to wafer manufacturing plants. Companies in this second category own the fabs to manufacture semiconductors. Fabs are clean rooms with various modules equipped to process integrated circuit devices. In this category, the companies design, manufacture, and market their own products. Companies in this category provide packaging services to silicon devices made by foundries into components and test them prior to shipping to the market. Companies in this fifth category are the equipment suppliers for semiconductor manufacturing. In this category, the companies provide the base materials and other raw materials required for semiconductor manufacturing. In the seventh category, the companies design, manufacture, test, distribute, and provide return or repair and assembly services for electronic parts. Companies in this final category provide a wide range of services in the value chain, from equipment maintenance, IT solutions, analysis, and consultancy, to the sale of refurbished products. The future of the semiconductor industry is bright and vibrant. Besides the setup of new companies' facilities in Singapore to produce next-generation chips enabling different innovations, companies are also investing in their employees, upskilling and reskilling, building the local talent pool to meet the challenges of advanced technologies.
Hello everyone, happy to see you all at today's Electronics Industry Day 2021 Industry Talk. I'm Jillian from SSIA. A warm welcome to those who joined our Electronics Industry Day event for the first time, and hello to all those who have joined us at the virtual launch and the industry talks in the last few weeks. All our previous events have been uploaded to our website, electronicsday.com.sg. If you have missed it, feel free to check it out. Okay, today we are very excited to have another 3 companies to present to us the latest trends and opportunities in the electronics industry. Let me go through some house rules before we start. We will use the Q&A feature to pick questions for each speakers. So inside the Q&A box, you can view posted questions and vote for the ones you want to hear, or you can type your own question and please include your name and school or company name with your question. And if you encounter any technical issues, please post your inquiries in the chat box. So Q&A box is for you to ask questions. Chat box is for you to raise any technical questions you may encounter. So here is the rundown for today's event. Later, we will have Jen from Corp presenting to us. Sustainability is our business, powering the energy transition in the electronics and semiconductor sector. And then she will be followed by Li Qiping from Lam Research, talking about the blue ocean in a new world economy. And last but not least, we will have Lennon from IME to present to us the topic sensors, actuators, and microsystems. So without further ado, let me invite Jen Tan, Senior Vice President, Head of Sustainable Solutions from Corp Industry Limited, to give us the presentation. Jen, please.
Hi, very good afternoon to everybody. Thanks to SSIA for having me here and allowing me to speak in this event. It's my honor to present sustainability is our business of Corp to everyone on the Zoom. A little introduction about myself. I have been in the renewable industry for the last 12 years. Especially this year, it has been a very exciting journey with the support, not only globally, but also from our Singapore government from all aspects, regardless of whether it's companies, schools, associations, and so on. Everybody is very supportive of sustainability business. Coincidentally, I also used to be from the semiconductor industry. I spent the first decade of my life, my working life, in Micron. I was there for about 10 years. And then after that, people tell me solar is sunrise industry. And then off I went and I started in solar in 2009. So today I'll share a little bit of what we have in Sembcorp, opportunities that we have, and how we view sustainability. Sembcorp is 100%, we are 49.5% owned by Temasek and 50.5% public listed. We have two main core business, energy business and urban. So urban business is mainly in the region, because in Singapore we don't have much industrial parks, right? But the energy business, whether it's gas and power, merchant and retail, or renewables and environment, that's pretty much in 11 countries. We have a total staff strength about 4,500 employees, right? And we are listed in the Singapore Stock Exchange. Our sustainable portfolio consists of wind energy, solar energy, and energy from waste. In total of our total energy mix, renewables forms about 22%. We have existence in Singapore, in India, in China, and in UK. A different kind of mix there, but it's all renewable energy. So the key track records that we have, currently we have almost 700 megawatt peak of solar PV projects in Asia. On the top left, you will see the floating solar. Actually, this is situated near the second link to JB at Tengah Reservoir. Is still under construction. We expect it to complete by second half of this year. We have about 435 megawatt in India. Some are constructed and some will be starting construction soon. We also have a 19 megawatt ground mounted solar farm in Singapore. This is going to be in Tuas. And we have more than 1,500 blocks of solar that we are going to construct, and all we have already constructed. So you can see we actually cover the land, the sea, and the air. I mean, not air, but roof, which is 16 stories high. Moving on after solar, but solar in the past, it used to be a developer game where we build, own, and operate. Big companies like to go and invest in it. But of late, solar is not just about an asset that we own and we generate revenue. It's about how do we help in the climate action plan, and how do we help to contribute to the sustainability and the green requirements moving forward. So as part of the Singapore's nationally determined contributions in the climate action plan, Sembcorp is also very excited to be part of this journey, whether it's the Singapore Action Plan or the Singapore Green Plan that the Parliament has just announced, right? So things like the carbon tax introduction, this is really an deterrent on how to reduce consumption, how to be more efficient, how to avoid, being taxed, how to reduce the carbon consumption. But other than deterrent, we also need to be very proactive in pushing the use of renewables. Unfortunately, in Singapore, there is not much wind that we can use, wind or, so solar seems to be the only biggest opportunity for renewable energy. And we have the opportunity to hit 1.5 gigawatt in 2025 and 2 gigawatt by 2030. This is the targets that are set by the government. So after we try to deter, we push the use of renewables, of course, we need to report how we are doing and whether we are really getting into these sustainable practices. So most companies, if not all, are being encouraged to adopt more sustainable approach and using renewables as part of our energy source to contribute and be part of the action plan to improve the climate in time to come. So many people have already started this a few years ago. In fact, some of our key partners, like and they are global companies. Facebook has signed a 20-year deal with us. We have also got UBS that signed a 10-year deal with us, and Google. So these big companies are the first movers in pledging sustainability movement, and we hope that many more companies will follow suit to help in this climate action plan. When I said many more companies, yes, indeed, there are a lot of companies who have over the last few years started to engage us or have already constructed solar on their roof. So we have contracted about 1,500 buildings, and these are currently already constructed or ongoing. So some of the company names, is very popular to us. In fact, we also have got semicon companies, Micron, SSMC, high-tech companies like 3M, Halliburton, all these are already solarized, and we hope that a lot more companies will come on board to solarize as part of this action plan. Okay, is sustainable solutions only solar, wind? I don't think so. It also involves other kind of solutions like energy solutions, environmental solutions, and also integrated solutions as part of reporting to help us in this. Energy solutions include chilled water system, distributed energy generation. How do we use renewable energy certificate and carbon offsets to achieve net zero? Of course, the EV topic is a very hot topic now. More electric cars need to be going on the road, so a lot of people will be excited about EV charging, buying electric cars soon. Before you know it, everybody is driving a Tesla on the road. Then there is also environmental solutions. So water is also a very scarce resource. Then we are looking at how to recycle water through rainwater harvesting. How do we treat wastewater and reuse them again? And also recycling and public cleaning is more and more the norm now that people are much more aware of sustainable solutions. Having all these solutions, it is very important that we also have a way to audit our actions. How do we use metering to record consumptions? And last but not least, to have a dashboard that shows us the performance of all our sustainable actions. There is, like I mentioned just now, water is also something that usually is forgotten. We often take water for granted. I think it's been many years where the government has also been, driving behavior on how do we save water. Even in schools, the students are being taught to save water. But we also need to look at, how to improve on wastewater treatment. How do we reclaim water, and how do we have alternate water sourcing? So these are the actions that really can help us to improve supply, treat and also recycle water. And Sembcorp do have a suite of all these solutions for our customers. Integrated waste solutions, like I mentioned just now, more and more people are interested in waste recycling now. So we've launched the Easy app where we have a recyclables collection through an app, and then we also have reporting and data for recyclables, so people become more aware and there is a better tracking mechanism. And importantly is we need to educate people, because in the past, the green bin, the red bin, and the blue bin, everybody puts everything in any bin. So with more education, it's easier to sort, and the waste it's much easier to recycle them. So I think Sembcorp is very much involved in all three aspects, providing an easy way, making sure that the reporting is done properly, and helping people to understand the need for this recycling education. Gone are the days where people start saying that, hey, if you don't study, you will end up being the waste collection uncle. I think we're trying to get away from this image and really digitize the act of collection of rubbish, and also the way we treat them to make them into usable products. As I mentioned just now, we can do many things, but it can become very difficult and cumbersome for a company if he has to manage the different kinds of energy that you consume, be it solar, retail electricity, energy efficiency, and then after that, the type of water you are saving, you're treating, and how do you recycle the waste. We feel that it is important to have a dashboard where we can track the targets and at the same time report our actual performance. So this is a dashboard that we actually tailor-make for our clients, and depending on the needs of the clients, we do provide this solution. With all our actions and our plan, we actually received some awards and recognition. So we've gotten the Apex Award for corporate sustainability, and we also won the Solar Power Company Award of the Year for best practices, I think last year, from Frost & Sullivan. Okay, back to a bit of a track record in semiconductor and clean rooms. We understand, like I mentioned, I spent the first 10 years of my career in Micron, right? And I think safety requirements, quality and compliance is extremely important. Operational optimization with customers, of course, is crucial. And understanding of the clean room requirements during our construction. I mean, not only clean rooms, it's the safety aspect, the quality aspect, and the importance of the entire manufacturing process is extremely critical, especially for all manufacturing companies. So when we do solar, we pay very special attention in the quality and the safety of our construction. And having done some of these factories, we understand the needs, and we pay extremely critical attention to the needs of our customers. So what do we see as potential sustainable solutions for semiconductor and electronics industry? And we hope that with this sharing today, we can bring more of the kind of companies to join us in our contribution to the climate action plan and our sustainable solutions journey. Of course, the easiest way is to install rooftop solar. Unfortunately, not everybody has a big roof like the one you see, right? So we also can look at using off-site solar, which we have in terms of renewable energy certificates via the Sembcorp REX platform. There is also the potential of using the carport solar with EV charging. Some manufacturing that has wastewater treatment and water recycling can also engage us in this activity. And of course, I'm sure every company has waste and has the need for waste management and recycling. So these are the few services that we can work on for the industry. And we also welcome, discussions and see how we can brainstorm for more solutions that can help in this journey. This pretty much sums up my brief introduction about the company, about the solutions that we have. Yeah, and I think we look forward, be it industry partners, be it customers, we also look forward for people students or employees to join us, because I think this is a very interesting journey that has a long way to go, and we are just at the beginning. Look forward to meet any one of you soon.
Thank you, Jen.
Thank you.
So before we take in questions for Jen, let us play a corporate video of Semiconductor to let you know more about the company.
Hi, I'm Sean.
Hi, I'm also called Sean, but I'm Sean Tu, and Tu is really my surname. I started at Semiconductor Solar in September 2019 as an operation and maintenance intern. In O&M, I spent my workday learning about solar projects across the electrical, mechanical, and civil engineering aspects.
I've always been interested in renewable energy as the whole world is talking about becoming more sustainable.
I think the responsibility of reducing carbon footprints lies in our generation.
Semiconductor is one of Singapore's largest homegrown international renewable energy player. It feels good to be doing my job and helping the environment at the same time.
It was easy to choose Semiconductor Solar because it invests in young talents and has a solid training work plan for interns. The Semiconductor Solar internship offers extensive on-the-job training, where experienced engineers impart their knowledge on software such as Helioscope, Google SketchUp, and also PVSys.
Besides creating the engineering drawings for the projects, I also got to see the projects that were completed based on my drawings. It's such a good feeling to see my drawings come to life in a commercial project.
The main challenge of being an O&M intern was the need to respond quickly to real-time solar performance monitoring system alerts and to rectify the issues in PV system in a fast and accurate manner.
I've learned that every project has its challenges. What is important is how we bounce back after every setback to keep the project milestones on track.
Throughout my internship at Semiconductor Solar, I work well with my senior colleagues who share valuable work advice and life lessons with me.
For me, Semiconductor Solar gives me good career prospects and it offers me stability and support to grow my skills in the renewable energy sector. I also like the family-like work culture where every department is united as one team.
I would recommend Semiconductor Solar to any fresh graduate who wants to grow in the renewable energy sector.
So come join us at Semiconductor Solar.
Okay, now is the time for questions for Jen from Semiconductor. So if you have any questions, please type in your question in the Q&A box on the panel at the bottom of the Zoom frame. So Jen, maybe I start with the first question. So if just now you talked a lot about like the solar projects that Semiconductor is doing. So if I don't have any solar background, am I eligible to the jobs?
Of course, when I started Semiconductor Solar 3 years ago, actually there was only 2 employees who knew solar. I have in my organization now we have a staff strength of almost up to 70 people, of which 30 are fresh graduates. I think fresh graduates come, what they know is the nice nasi lemak outside NUS, and the whole life and soccer. So I think what they came with, which is a very important attribute, is attitude. So with the correct attitude, we have the correct training program to train everyone. So we've got a robust training program. And so far, I think in the video, you see the 2 Seans, they have learned very well and they are independent, executing and managing projects and engineering now. So the answer is no, we don't need, we just need the correct attitude. We'll provide the adequate training.
Okay, thanks. So here come 2 more questions. First one is, what are the criteria in joining Semiconductor as a graduate?
I just answered that question. I think good attitude. Okay, one thing is we are always outfield. We like to climb the roofs, and girls who don't really like being in the sun will have an issue because you can't be fully wrapped up, right? So that is probably the only issue, or if you're extremely afraid of heights because you're on the rooftop. Otherwise, the right attitude and passion for renewable energy will bring you a long way.
Understand. And some people that are already working, I think feelers asking what are the requirements for an quality engineer in foundry business to switch to renewable energy sector.
Sorry, again, can you repeat?
What are the requirements for an quality engineer? That means she already works as an engineer in foundry business. So how can she switch to renewable energy sector in Sembcorp?
Well, in Sembcorp, we also have quality engineering, but that is to check the work of construction engineering and the construction of the solar. Like I mentioned just now, quality and safety is extremely important for, especially in semicon, right? How do we connect the wires? How do we label them? So the qualities that she has in the foundry, I think she will have she'll be very meticulous. She will have a very good structure in identifying of identification of issues. With these same traits, it is definitely applicable in the solar industry. So instead of being in the clean room, she'll end up on top of the roof under the sun.
That's good to know.
Otherwise, it's very similar traits required.
Yeah, so there are definitely opportunities for them lah.
Yes.
Okay, another question. Farid asking, you mentioned you were from Micron. How do you convert yourself to Sembcorp? I mean, he means like what were the relevant skill sets that you had and was useful to in your career transition?
Yeah, I think I was in that time back then was called Tech Semiconductor. So some people will know Tech Semiconductor, right? So I was mainly in planning, structured, what is the input, then what is the process and what is the output. I actually, before joining Sembcorp, I went to this company called REC, which is the production of solar panels, using the same traits that I had. So when I come to Sembcorp, from renewable and from tech to REC to Sembcorp, pretty much the same traits, right? Is all about manufacturing, production excellence, operations excellence.
Yeah. Understand. And another question is about COVID. How does COVID-19 impact the industry and how to cope with COVID-19? I think he's asking like in the business wise, how do you cope with the pandemic in the last year?
Yeah, I think COVID-19 is very unfortunate and it makes a lot of people inconvenient, right? But we just need to make sure that we take care of the health of not only our employees, but also our suppliers and our clients. So we used to just, start work at 8 o'clock, just doing the usual toolbox meeting. But right now we have a lot more extra measures. Of course, it is higher cost, but we are learning by the day and we are improving the efficiency again. It's not as easy as it used to be. I think some of the companies, if not all, has team 1, team 2. People are not allowed to mix around. So we comply with each and every company's requirements when we are there to do construction. But we do make sure that everybody is taken care of, regardless of whoever it is, our customers, our employees, our contractors. So we have a very stringent set of safe distancing requirements that is embedded into our SOPs.
I see. So another question from current workforce. So leader asking, he has been working a long time in manufacturing, 14 plus years in manufacturing and operation relevant work. So he wants to know how he can do a career change to join Sembcorp.
Wow, well, my customers scold me, man. I'm stealing all there. Well, I came from REC, which is a manufacturing company, right? We manufacture solar panels. So how did I end up from manufacturing to construction? Like I said, in everything that we do, there's always a plan, then there is execution, there's a PDCA, Plan, Do, Check, Act, right? So there's a plan, there is execution, there is checking, and there is after that, if there is issues, then after you go and fix the issues, right? So from operations, manufacturing environment, in aircon, in clean room, now we go up to the roof, the things are rougher, tools are heavier, but the act of the entire construction process to me is pretty much similar. The processes that we use, the actions that we take is very same. So if there is such conversion requirement, I guess you only need to understand, the actual process of solar construction as opposed to your actual process of, let's say, producing a piece of wafer. But the attributes that you have as a project manager versus your manufacturing engineer in the production line, to me, is quite similar. You manage people, you manage schedule, you manage budget, you manage time, and you are pressured by output, and your boss becomes very unhappy if things don't happen the way they plan it to be. Yeah.
I see. And another question from Hongbo. He should be a fresh PhD graduate. He's asking, what's the role of a fresh PhD when joining actually it's when joining Sembcorp and how to prepare the interview.
Okay. You see, a lot of us that is very experienced in what we do are normally blinded by what we know. What we don't know is what we don't know. And some of these PhD students I think somehow they got this special supernatural power where they can see what you can't see. That's the reason why, there's this thing called AI. If you ask me, do I know AI? I tell you I don't know, because I don't have that kind of special power that I can think of AI. But we need this kind of PhD students to think out of the box. What we normally say, I cannot one, it's very difficult, because we have been so used to it the way we do it. And PhD students, when they come in, they need to give us a different perspective. And one of a very good example that I've been looking for, and if this PhD student has this capability, I'll be happy to talk to him, is solar, unfortunately, is still a very construction-based, to build solar, you need a lot of arm strength, and you need, unfortunately, we are reliant on foreign workers. So recently, we are trying to see how do we reduce the reliance, or we still can be reliant, but we don't make the job so difficult, because they're carrying very, very difficult, very heavy slabs, and it's very heavy weight and a lot of muscles and energy required under the hot sun. So in invention of special equipment that can help the construction process, to me, is a very critical milestone. I think I've seen through the 200 mm to 300 mm, I still can remember, that was like 10 years ago, 200 mm to 300 mm conversion, where operators used to carry cassettes from machine to machine, from last time we call lock point to lock point to process. Then after that, it all went by automation, AMHS. I don't know what's the long name, but automation system, and we don't need operators anymore. So because of this experience I have in semicon, right, I always tell my people, can we do this in construction? People look at me with eyes big. So I need PhDs to really think about this and help to make a breakthrough. So I look forward to that day.
To bring in innovation.
Yeah.
Yeah. And here is another question regarding the working life in Sembcorp. Someone asking, does Sembcorp support further studies plan?
Well, I am doing my EMBA at NUS. Actually, as we speak, I'm having a lunch break now. So the answer is yes. We have got Sembcorp scholars. We have got overage students like myself, and then we do. But I think it also depends on the, what's that thing called, the economics of the company, right? If we do well, of course, all these things does happen. Then during downtime, it's held back. So it really depends on the company and at the time lah. But so far, in my experience in Sembcorp, yes, they do support education.
Good to know. So given the timing, maybe we answer the last question from Gerald. He is asking about internship. So what is the eligibility? How can he be eligible? How is the eligibility to apply for interns? He said he's a EEE graduate.
I look forward to his participation. I am a big fan of students. So in fact, I think we have like 10 to 15 interns at any point in time. So there is internship application program that our HR works with the different tertiary educations. I'm sure his tertiary education is also working with us. But if he feels really, he couldn't get through for whatever reason, sometimes, you have these blue tape issues, he can always write straight to our HR recruitment and sound out, or even write to myself if he needs to. We will be happy to accept interns. And I feel, like I said, other than PhDs, the other group of people that can give me out of the box view is really the students.
Agree. And thank you, Jen, for all of your answers. So for those unanswered questions, Jen and her colleagues will be in this chat room to type in the answers for you all. So thank you, Jen.
Thank you. Thank you, everybody.
Thank you. So now let's move on to our next company, Lam Research. We will have Lee Chi Peng, Senior Technologist and Technical Marketing Manager from Lam Research, to give us a presentation on semiconductor industry, the blue ocean in a new world economy. Chi Peng, please.
Hey, Jillian, thank you. Let me share my screen. Let me know once you can see. I suppose you are good right now, Jillian?
Yes.
Okay, great. A very good afternoon to all of you. Again, thank you for taking your time to attend this virtual session. In fact, it's very interesting world we are in, what I be calling the new world economy over here. So why is it a new world economy? Post the COVID, or rather in the midst of COVID-19 pandemic right now, a lot of the stuff has actually gone virtual or online. For example, like the today's talk, typically we'll do it in some conference center, we can do face-to-face introduction and so on. But today we have to resort to a virtual way. And this is the new world economy that we have done over here. But have you actually wondered what is enabling this new world economy, or the virtual world, or the technology that is driving this? The answer, in fact, is actually the semiconductor industry, right? And today's presentation is titled such that I'd like to share with you what is a semiconductor industry and how is it the new blue ocean in this new economy, right? Before I move on proper to my presentation, quick introduction of myself. My name is Chi Peng. I have worked in the semiconductor industry for about 17 years by now. I started off as a process engineer in Novella System. Novella System was actually merged into Lam Research, and that's the company I am today. So literally, in a way, I'm in the same company, in the same industry for already 17 years. Today, I'm working as a senior technologist and also a technical marketing manager. Right? Glad to be here, honored to be here to share with you some insight that we see from Lam Research on the semiconductor industry. So this is the outline of my presentation today. I will first begin by giving you a very high-level overview of the industry. It's very vibrant, very exciting, very complicated industry. Typically take a long time, but let me do it as short, as easy for you to understand as possible. Again, the industry is very fragmented, very big ecosystem. With that, Lam Research may be new to most of you who are not in semiconductor, or those who are in semiconductor may not heard of Lam Research as well. So I'll give you a quick overview. Who is Lam? What do we do in this industry? And finally, we also like to share with you some of the company introduction and what are the opportunity for you as perhaps some as a job seeker to come to our company. Okay. So let me start with the industry overview. So most of you, I believe, are very familiar with the list of names that I'm showing over here. After all, they are ranked as the top 10 semiconductor supplier by revenue in the year 2020, right? Some of the name are very common household name like Intel, Samsung, TSMC are also very popular of late because they are the leading edge player in the industry, and there are some bottleneck in the industry, in the automotive chip, for example, and company, government are going to TSMC to drive that replenishment of the stocks, right? Beyond that, there are names like in Singapore, you have Micron. There is also the fabless company like Qualcomm and so on, right? But where I want to highlight over here is the industry doesn't surround just around this top 10 company. It is a very big industry. So the semiconductor industry size is about 450 billion in total, okay, by 2020. In the primary ecosystem or supply chain, there is the design player, there is the manufacturing player, and there is the package and test player. Okay, so design, there are names like Apple, you're very familiar with. And in the manufacturing space, we have TSMC that I mentioned earlier on. And then when the wafer have go on to the back end for testing, because you want to make sure that the phone you use is working properly and won't have short lifespan. So we have company like Amcor, TSMC, ASE, and so on doing all this testing. Okay, but supporting this industry are what we call the supplier ecosystem or supply chain supplier itself. Okay, so to do a design, you need to have some IP, you need to have some design tool. So there are companies like Synopsys that provide the design tool, and there are companies like ARMS that provide the intellectual property design for this company to type on. Okay, this is where Lam Research come in. There is another category, what we call a capital equipment supplier, and Lam Research is one of the leader in this equipment supplier space. And besides to build the stuff, you always need material. So we have also a group of material supplier like Eligibility, Technique, TOK, and so on. So hopefully this give you a very big overview of the industry names in the ecosystem. All right. Now, why is semiconductor getting much more important? This is related to how computer intelligence are driving the industry revolution. We started off with steam engine enabling Industry 1, and then assembly unit in 1870 driving the Industry 2.0. Some programmable logic, this is where some logics are being, some digital stuff are being implemented to enable Industry 3. But today, we are hearing a lot about Industry 4.0. Essentially, it's leveraging the big data, putting a lot of sensor in the machine, making a smart machine such that it can collect data, analyze via artificial intelligence, how to optimize the production, and so on. So we call this the cyber physical system revolution. All right, but putting something into more layman term today, I'm showing you here 3 areas where semiconductor technology is transforming the industry. Some of them are just the beginning. On the far left side over here is the medical system. So doctors, we are seeing increase in telemedicine, for example, like you have to see doctor do it virtually at the consumer side, but at the industry side, they are using AI, they are using very advanced server to do simulation so they can drive design of drug, design of medicine as soon as possible to reduce the time to market, right? On the automotive car, as Semco has mentioned, a lot of electrical vehicle is coming on board, and electrical vehicle also requires some use of semiconductor. But where we are getting more excited is a generation beyond the electrical vehicle, what we call autonomous driving. Tesla is one very big example as big champion of this EV and autonomous driving. So this is being enabled by the semiconductor industry. Okay. On the third side, maybe not so familiar to people, to those who are in Singapore, because agriculture are not a big thing in Singapore, although it's getting more attention. But in vast farming area like in US, for example, there is limited manpower to do the proper agricultural work. So what we can do now is using drones to capture how the green have changed in a very large area, using AI to map and study how is any area that is not so green, and then you need to put more fertilizer or put more pesticide, for example. And there's also self-driving tractor to do plowing, to do harvesting, and so on. Again, this is being enabled by Semicon, and these are all just beginning. Semicon are still having a long road to further enhance this industry, which is why I call it the blue ocean. Okay. Something else beyond the tree industry, I want to give additional example, but I won't go into a length that I will bore you down with so many examples. But you are familiar with PC and the mobile and automotive that I mentioned on. IoT, what we call Internet of Things. You have housing appliances today that can communicate over the internet, smart kitchens, smart light, etc. Right? Cloud computing is very familiar to most of you. If you use TikTok, if you use Facebook, the data all in the cloud, and machine learning are being used to tap on data coming from cloud, so that they can give you a better solution, better product. Like when you go to Lazada to do your shopping, what's the recommendation for you to buy? That's coming from the AI actually. Where everything coming up is the virtual reality and AR. You are so used to using your phone, but what if the phone is in the glass on your eye? There are products being designed at this point in time. So we see a very bright future in this regard. And robotics as well as medical, they have shared to some extent earlier on, right? So coming much more closer to consumer yourself, where you are much more familiar with is the mobile phone, right? 1983, I was just 3 years old by then. This is what you get, a 2-pound big giant, they call it brick, like they can hit somebody head. And the talk time is limited to just 30 minutes. But today in 2021, or this was iPhone 12 Pro Max launch in 2020, just 8 ounce. Video playback of 17 hours, audio playback of 65 hours. Imagine the transformation of technology that enabled it. If I move to next, in terms of function, earlier on is physical dimension. Functionality-wise have also changed tremendously. First generation, just making phone calls. Today, you can use it to replace many things in your desk, right? As a day planner, appointment planner, it can be used also as GPS. I used to buy a standalone GPS, and now GPS integrated in the smartphone. You can use it to check your stock, to see whether your portfolio is in the green, how much you have profit, and you can use it to play games, for example, right? Or have social media. The capability of a phone have changed so much over the year. And there are more to be seen in the mobile phone as well. Okay. Now, what is enabling this transformation in the products is essentially the integrated circuit, or the brain of the hardware. Okay. Intel first introduced this. This is a first microprocessor. Look at number of transistors. Number of transistors correlate to the performance. The more transistor you have, the better the performance you have, right? It's 134,000 transistors. Apple A13 Bionic, which is the application processor in the iPhone, they have about 8.5 billion transistors today, right? The technology used is about 7 nanometer technology, whereas back then it's a 1.5 micron, very big scale change, all right? So to give you a sense of scale, because these are just numbers, right? So what we see is this is like a wafer. The wafer contains all the integrated circuit that I mentioned to you earlier on. They are processed in equipment run on Lam Research product in general. Okay, so this wafer will zoom in further. You get the chip. Okay, every phone will have one of these chips. Of course, they have many chips in the phone, but this is one example of the chip. And I mentioned to you earlier on, the transistor is very key building block of a processing chip. Okay, so if you zoom in further, you get the transistor. And what I'm showing you over here is a 14 nanometer size kind of transistor technology. Today, we are moving way below that. Okay, but from 14 nanometer, what exactly is a 14 billion of a meter of so many zero that you see. All right. If you compare that to a red blood cell, okay, a red blood cell is about 8,000 nanometer or 8 micron, right? So relative is still many times smaller than the red blood cell itself. Another way to compare the scale will be your fingernail growth. We show here like your fingernail actually just grow like 1 nanometer per second, and we are developing something that is less than 14 nanometer today. Okay, so hopefully that gives you a very exciting overview of the industry, what the technology have played, how it has changed your life, and where we think it's becoming more prevalent. The next section, let me quickly walk you through what LAM does in the industry, right? I have early on shared we are the equipment supplier. As a result, we are actually a leader in this area. So virtually every leading edge devices inside your electronic product are made using our tool, right? By company like Micron, company like Global Foundry, and so on. Okay, so as I have mentioned earlier on, this is the IC. At the heart of every electronic is the microchip. And this microchip, you need to build very complicated electrical connection inside the chip at nanometer scale. Okay, and to create this, you can use is 1,000 over machine being used. LAM serve some of this percentage of this machine. So most of the time, customer buy our tool to do some of the processes. Okay. So how is a chip being made inside the factory? For example, you have to go through these semiconductor processes. It get repeated, it get modified to some way, but this is a very high level overview. So you have a wafer, a 300 millimeter circular piece, and then you do deposition of material. You have to put something first, right, before you can create structure. Okay, so you deposit material. Blue color means is where LAM has a machine, and then you have to draw like a floor plan, how you want to etch, how you want to remove material to create a structure. So this process is called lithography. Okay, putting a floor plan. After which you have starting digging, or what we term as etching in the industry. Okay, etch to create the structure. Okay, and the floor plan that you put on top, you have to strip it away and clean up any particle, any residue, any dirt that is not shouldn't be there to begin with. But these are very, very small structure. Any kind of particle will cause damage to the devices, and that's the last thing you want. Okay, so you do stripping and you do cleaning of this structure. And finally, you have to fill up with the metal material to conduct electricity, conduct current. Okay, so this is what we call a deposition, filling itself. Okay, so LAM, as I mentioned, we are one of the biggest leader. So we serve about 34% of this industry segment, and we bring to the market multiple equipment, various names, interesting names like Da Vinci over here for the cleaning system. All right. So additional example over here is a schematic to show the progress of the effort we do in the semiconductor technology. You are very familiar with Burj Khalifa. That is the tallest building today based in Dubai. So if you look at the highest point to the lowest point and the width of this building is about 9:1 ratio, right? This is a mega structure. We are building a very nano structure instead. Okay, so this is a memory used in your handphone. You call it the 256 gig that you buy, the 3D NAND structure. So we have to dig a very, very deep hole inside here if you look into this tower. All right, and then we have to fill in with certain material. That's why we call it inside out deposition. Inside depth all the way to the top. Okay, so this structure is more than 50:1, actually to 100:1 already by today's generation. Right, it's 5 times the Burj Khalifa tower. Just show you at nanometer scale, we have to do very, very micro or nano structure. Right, very, very challenging, but very high achievement, high satisfaction if you can do it. All right. I'll move on to the last section, which is about LAM research and how it can be relevant to you today. And that's also the reason why I'm here to share a little bit more about the company. We serve multiple products. We have the product to do the material deposition, to clean and to create structure on that wafer. And we also able to do cleaning on the wafer. Of course, nowadays, you need to have some analytics, you need to have some process control to make sure the yield is high. So we have teams that focus on artificial intelligence, data scientists to do this activity as well. And being a company that sell a machine equipment, we also need to have a warranty support. So there is a service and support option over here. Okay, we are among the leaders since 1980, about 12,000 employees with global presence. We are a multinational company. North America, Asia, and Europe. As of 2020, we have a record revenue, about 11.9 billion in revenue. We invested heavily in R&D because in technology sector, you need to continue to invest to be the leader, right? So we put in a lot of money, about 10 to 15% in general to R&D to keep our position in the leadership side compared to the competitor. Okay, this is just to show you where are the global presence. Singapore is definitely one of the key areas we are based in today. And then I would like to share with you what are the skills we need in our hiring. We hire like engineers for the technical position. We also hired staff, supporting staff in the non-technical position because now we're grown to be a big company, right? So in the technical side for engineer, basically some engineering background will be will be needed. Chemical engineering, electrical engineering, material science, we're open to that as well. Okay. In the non-technical side, we are expanding like supply chain, finance, some HR as well. We do hire because every of this industry, they will also have this others non-technical section. So we do hire those positions. Okay. Most of the people that we have in the company today, 90% are over a bachelor degree, right? But many of them has advanced degrees, particularly in the US side. They are PhD holder because we need someone who are very good in R&D, right? So that brings me to the last slide. This is a very nice phrase that I really want to share with you. In LAM, we think we move the atoms that actually move the world. So what do we mean by that? To create a computer chip today, as I mentioned much earlier on, is a nanometer kind of process. So it requires very high precision on the scale that is so small, you cannot see literally. So you have to use equipment, a lot of way to see that small scale, right? And it's very hard for us to understand because when you go very small, the law of physics changes tremendously, okay? So at LAM, we are all atoms engineer. So regardless if you are an engineer that's working in the R&D or supporting the customer, or if you're a technician to help us do some of the support, or a product specialist, or whether you are a senior leader or you are a recent graduate that joined our company, you are actually, in our view, helping our customer like Intel, TSMC in Singapore, will be Micron, UMC, and so on, helping them to manipulate the building blocks of atoms. Okay, and these atoms are where it built the transistor. Remember, the transistor built the chip, and the chip are used in electronic product, and these electronic product are now transforming the various industry across the world. And with that, you move the world. All right. So that ends my presentation today. But before that, if you are interested to learn more about LAM research, what are the career options that's available? We are hiring today. So feel free to scan the QR code that is shown on this image, right? But if you miss the QR code for whatever reason, you can also we have missed out putting the email address of a contact email address. So feel free, you have my name. Feel free to look through my LinkedIn, get my email address, or contact me via LinkedIn. I can also help to direct you to the relevant party if needed. All right. Again, thank you for taking your time to listen to this presentation. Yeah.
Thank you, Chiping. So here comes the Q&A time, and we have the first question here from Hongbo. May I know any opening position for an applied physics PhD, and what are the requirements? Maybe Chiping, you can also introduce to us some of the job openings in LAM now.
Right. So the two key positions that we looking forward right now. One, I mean, they are always the technical position. So we are looking into service engineer, senior service engineer. And in this service engineer, we are very open to options. So if you are triple E student, mechanical engineer student, even a physics engineer, we are welcome to apply for the position. So to check the QR code, go to our website, we list down very detailed what are the requirements. Ideally, for the senior one, we want someone with proper experience, but we are also hiring fresh new college grad. We call that NCG. We have been hiring a number of them over the years because we will provide the proper training. So for a PhD student like in physics, we also welcome you to take a look into the career option that we have, right? But just to add on, beyond the technical side, we are also looking into sales manager position right now. So anyone with interest to do a sales position or trying to switch industry, but if you think you bring very transferable skill set, we are also welcoming you to take a look, apply for the job, and go for the interview.
Okay,
All right.
and yeah, our colleague Rebecca has just typed in the link for the career opportunities at LAM in the chat box. So
Oh, that's
those who
great.
are interested can click on the link later. And let us move to the second question. Is from Christopher. He say, very nice presentation. And is LAM research also involved in quantum chips research?
Quantum chip is one of the upcoming research in the industry for sure. At this point in time, we are not heavily or actively involved in that area. We are very focused in the next 3 to 5 years kind of development at this point in time. For example, we are investing in new technology in because as the chip go down to 5 nanometer, going down to 3 nanometer, there will be a limit somewhere sooner or later. So where the industry are heading through is more on what we call heterogeneous integration. So that is one way to extend the Moore's law if you are familiar with the industry, right? So we are focusing, one of our focus is on the area right now. And beyond the heterogeneous integration in certain other technology is to use 3D instead of 2D transistor. 2D transistor are placed side by side, but in one of special memory, they have gone 3D manner. So some of the research or work that we have investing are mostly in this area. Quantum is a bit longer than we want to invest actively at this point in time.
Understand.
Mm.
So here comes two questions regarding the different job opportunities. Ziwei is asking, is LAM research currently open for internship? And Farad is asking, is LAM research part of the government SG United program?
Yep. Okay. So on the first question about the internship, we do have opportunity for internship, but what we recommend for you is work through your university. Typically, we work with the university and list the internship opportunity. So go through the university channel that you have, and then we can look into the application from there on, right? That's on the internship option. The second one is part of SG United. Yes, we are. So in fact, we have been hiring a number based on that SG United program as well.
That's good to hear.
Yeah.
And another question is from an undergrad. She would like to know from May, she would like to know what is the job description like for a sales engineer?
Okay, so a sales engineer in LAM per se, I mean, it is a very high-tech industry. So in the high-tech industry, there's still some technical understanding that you will need to have. So a sales, he will need to learn about the product. Of course, you will have a team to support the sales. He will help to, he'll go engage with the customer to make sure that the customer understand what are the product that we have. That's one of the function. To job and to follow through with the sales opportunity because customer may want to buy the equipment and the sales engineer will have to understand what are the type of equipment the customer is looking to buy, what's the configuration, because our equipment is really in millions of dollars, right? So it's very complicated and a lot of configuration. So the sales engineer responsibility also include understanding what are the configuration when the customer want to buy. Beyond that, building the relationship with the customer is one of the key things in every sales job, I suppose, right? So that will be another scope. Okay. The other portion will be a sales engineer also have very, I would say very, I mean, in a way, exciting but challenging. So you need to have very good interpersonal skill, communication skill. You work with multiple parties, so you bring that business deal to the team, but you have to work with our US headquarters to understand what is the right product for our customer, what's the right pricing, and so on.
Yeah,
I hope
because
that helps. Yeah,
they are the important people to bring in business for the company, right?
exactly.
Yeah, and another question from Jack Chin is regarding for mid-career job seekers, what are the job opportunities available for them? Is there any relevant working experience required?
I would say for mid-career, in the technical area, we are hiring more on the technical side today, as well as on the sales manager. For example, if you have a sales relevance, we may be able to look into, we'll look into the transfer skill set, because as you know, every job, there are some soft skill that need to be there, right? So for example, how do you work in the team? How do you work with people from different area in the world? Because LAM is a multinational company, so we have to work with people from America, for example, and it is a matrix organization to some extent. And are you achievement driven? Are you having certain kind of, we are very strong on core value. Are you someone who build trust, respectful? These are the attributes that we look at. And then on the technical side, depends on where you are looking for. If you are looking at a technical job, and then you don't have a technical background, which we understand, because even our technology changes. What I learned about 15 years ago no longer apply as much today, because technologies keep on moving in the semiconductor world, right? But what is key is your troubleshooting skill, your problem solving skill. For example, do you adopt a certain methodology? That would be very useful. The rest on the technical side, we can provide the proper training in that regard. Right?
Understand. Thank you, Chi Ping. So for those unanswered questions, would Chi Ping and your team type in the questions in the chat box, in the Q&A box? Yeah.
Yeah, sure.
So thank you, and thanks for your time for the presentation and QA. Now let's move to the last but not least company for today's event. We will have Lennon Lee, Deputy Head Scientist from Institute of Microelectronics, IME from A-Star, giving us a presentation on sensors, actuators, and microsystems. Lennon, please.
Hi, Jillian. Thanks for the kind introduction. Let me go ahead and share my screen. Can you see my screen?
Yes, can see.
Okay. Great. So wanted to share this image because I guess I already gave the answer just now when you saw the overview, but basically, what would you think of when you look at this image? So some of you may recognize the different parts of a phone. Maybe some of you in the audience may even realize this is a iPhone 12, if you are really a Apple fan. So, but to many of us, many of my colleagues, and maybe some of you also in the audience, all these are semiconductors. So you can see all these different chips coming in, creating this product that you hold in your hand that enables all kinds of functionalities. So all the chips you see here, the logics, the memories, the communications, and even all kinds of sensors. So ultimately, semiconductors are really pervasive in your life. And I think without them, all of us can say that it's almost hard to survive without electronics in the current world. So I'm Lennon. I'm the deputy head for the Sensors, Actuators, and Microsystems department at the Institute of Microelectronics. And today I'll be sharing a bit of what we do here at the Institute of Microelectronics in A-Star. So before that, a brief introduction on the R&D, research and development framework in Singapore. So our research framework is organized firstly by the Research Innovation Enterprise Council, and that is chaired by our Prime Minister Lee. And under that, we have the different ministries. So there's the Ministry of Trade and Industry, Ministry of Health, and Ministry of Education, and their respective grants that they manage. And under these ministries, there are the direct funding agencies. So these are usually the key agencies that have research and development as one of their key objectives. And A-Star is one of the key funding agency. And there are many A-Star research entities that are the actual research performers that do the actual R&D work. So IME is one of the research entities, and you can see that there are many of them, about 15 or so of them, and is grouped into the blue ones that you see are under the Biomedical Research Council. So these research institutes are mostly doing biosciences research, and there's the gray ones here that do more on the science and engineering. And then IME is this orange one here, and it's under science and engineering. So there's a huge range of different R&D jobs actually that's occurring in A-Star. So Institute of Microelectronics, it's our executive director is Prof. Dim Lee Kwong. He's a well-known professor from the US, UT Austin, and his famous in the semicon academia and also in the industry itself. And our key research areas, which I will also talk a bit more later on, are AI at the edge. So this is creating AI chips. And then you also have system in a package where you try to combine all of them using chiplets or other methods of integration to form a complete system. Sensors, actuators, and microsystems, that's the department that I'm in. And we work on different kinds of sensors, which will go a bit more detailed later on. MedTech is also one other area that uses semicon to actually address problems in the medical industry. And then we also have RF millimeter wave working on 5G. Heterogeneous integration, I think previous speaker mentioned also this is one hot area where you actually can create additional functionality rather than doing the traditional Moore's law. Silicon carbide power electronics is another growing area where instead of the usual ways of doing your power management, you can use chips to actually handle it and help to shrink the form factor also. To do all of this, definitely we need a good infrastructure. So that is coming from the facilities that we have across Fusionopolis and Science Park. So ST Microelectronics is probably one of the largest MEMS player, and we have a lab in FEB that was announced in the press, I think, recently. And we are also building up a silicon carbide pilot line. There's also advanced packaging pilot line. And with this, we are able to build different chips that you see here for various different functionality. So IME is divided, as previously mentioned, into these few areas. And our area, and my area here is covering chemical sensors, optical sensors, RF MEMS, acoustic MEMS, and also emerging memories. So this is quite a bit of different topics. So I will try to spend a bit of time to go through them and hopefully get your interest in why they are so important in our current society. So when we look at the semicon industry itself, so it's probably way more than what I can show on a single slide, but this is just some snippets of what has happened. So you started with a transistor. In fact, even before this, there's a vacuum tube, which finally was made into a semicon version with a transistor. And then slowly we built up to just a simple device, a clock, finally to your PCs, your large computers in the past, and finally now to this small smartphone that is way more powerful than any PC even then back in the past, which was larger by at least 10 or 100 times. And then moving forward, of course, there are going to be many applications which all rely on semiconductors. AI, one of them, quantum. You also have autonomous vehicles, drones, and many of these upcoming exciting applications that all require semiconductor chips. And in fact, if you're also wondering how it's playing a role in the public sector, you can see that in the public sector itself, there are many different ways that sensors, in fact, or semiconductor chips can play a huge role. So we have, for example, in the underground substation, you would need some gas sensors to monitor this SF6 gas that is used for the insulation. In the deep tunnel sewage systems, you would use a leak and flood sensor to monitor. You could also use a leak and flood sensor to monitor it. Also, even in the transport systems and all these areas here, if there is underground network, the air quality can also be monitored to determine how good the air is. And also, even further down, as you go deeper, the structural integrity is very important, and sensors to monitor that would also be crucial. And all this, of course, besides the sensors, requires the logics, the memory, and of course, the communications to get the information out. So when we look at the sensors, actuators, and microsystems, some of the teams that we have here are working on chemical sensors, RF MEMS, acoustic MEMS, optical sensors, and emerging memories. And so supported by, so these teams are all supported by our integration platforms and our system prototyping. So we do all the way from the device level, looking at the material itself, improving on the process, the material quality, finally doing the processing to get the necessary device shapes and topologies. And then after that device is done, even going to the full systems prototype to build up into a prototype product level that you can actually use in a real world applications. So some of the highlights is we've worked with many industry partners. We also have a large team here, over 40 of us, and we all work very closely with each other, with also the various industry and public sector partners, and to do various kinds of interesting projects, cutting edge research. So for chemical sensors, why is it so important? I think this maybe everyone is probably quite familiar with the haze in Singapore, and also even with currently right now, as you know, COVID-19. In fact, one use for chemical sensor or gas sensor is actually helping to monitor the indoor air quality. So a CO2 sensor was observed to correlate with the risk of COVID-19 transmission indoors, such that the higher the CO2 level, meaning there's less circulation of air from the outside and a higher chance of the air being recirculated if there is someone infected with COVID-19. So besides this, applications close to us, it's also used in various emissions monitoring for the air quality, and also even in process and controls in all the other industries. So another area is RF MEMS, and for this, I think you probably have it in your phone without realizing it. So this is one of the way for the phones to work in the communications. This acts as a filter. So this is again a huge growing market, and it's requiring different physics, combination of different physics on a single MEMS chip to make it work. So one more area that we work on is acoustic MEMS, and for acoustic MEMS, maybe to some application that is close to all of you could be, for example, medical imaging. So when you know there are, if you have, if your wife is pregnant or you're pregnant and the infant is in your womb and they want to check the health, then one way is to do ultrasonic imaging, and that would not be at all harmful at all to the baby. So you know the health of your baby and how your baby is, how your baby is. So this is one way to actually do this kind of imaging. And of course, besides that, microphone, hydrophones, and in the future, very interesting haptics, gesture recognitions could also be achieved with acoustic MEMS. So another area is optical sensors. So optical sensors, maybe you might think this is not semicon, but actually this is a very hot area that's up and coming. So it's using meta surfaces to actually replace the lenses with a single flat piece of semiconductor chip. So with this chip, you have certain nano antenna structures on top, and you can achieve all kinds of functionality. So this is, in fact, one of our capabilities also in producing this flat optics. So the designs are usually these nanostructures that directly interface with the phase of the light, and then coming out with a different functionality at the end after passing through this meta surface. And of course, there are many areas of innovation done throughout this whole processing in order to finally achieve a structure like this. So this also, as mentioned, has very high aspect ratios and something very challenging to do, but it's what makes R&D exciting, always pushing the frontiers. Emerging memories, another area that we work on, and that is with using RAM, that is called resistive memory, and also in the future working also on FERAM. So for RAM, like this is one way that we can apply it for neuromorphic computing. If you know, that's how we can potentially simulate how the brain works with different resistive states. So this is a new kind of computing architecture versus the current method of computing. And besides that, a brief introduction on our integration platform. So these are some of the images that you see. This represents actually different materials. So maybe it's unclear to you at this point, but maybe if you join our industry later, you will understand what it means. And it's how we actually communicate with each other on the device cross sections and enable this talk between the foundry, for example, and the design house. And of course, with these platforms, you can create many different applications. I mentioned previously all these acoustic MEMS, RF MEMS. You can also create inertial sensors, pressure sensors, gas sensors, and all the other sensors that you can think about. So this is again an example of how we could combine them to create an inertial combo. For example, those you see, those you have actually in your phone right now. Some of it combines accelerometer, gyroscope, and magnetometer into a single small package that you can see here. So all these are really micron scale devices. For the logics, it's even all the way down to the nano level. And finally, definitely talent is also needed in systems prototyping, where after we do the chips, we need to actually move from a simple semiconductor chip to actually the full end user application. So requires mechanical design, fluid dynamics, and also your PCB design, your electronics, and finally even your software, your UX UI design to create the interface. So all of this is crucial in order to create the final electronics product. So that's the brief slides that I've prepared. And then if you're interested for any careers in IME, so feel free to scan the QR code or also click on this link here. There are many opportunities here at IME. So of course, for internships and also people who want to go into engineering positions or research scientist positions, those are all available, and even industry development managers. So there are huge range of opportunities here, and then looking forward to hearing your questions. Thanks.
Thank you, Lennon. Thank you. We have the first question from Chong Sheng. He is asking specifically on neuromorphic sensors. So he wants to know about, like, are there any works in neuromorphic sensors under your team? And are there any relevant engineering projects done under your team of IoT on the edge?
Yeah, thanks. Thanks, Chong Sheng. So we do, right now what we are doing for neuromorphic is neuromorphic computing. So we basically use RAM to achieve that functionality. And I think if you are interested in it, feel free to maybe email us later. We have our website, so you can contact any of us, and one of the other scientists working here in IME can definitely help to answer more questions on neuromorphic. And if you're interested in joining our team, I think we'll be happy to have a look at it and talk to you about it.
Okay, thanks. And Chongshen, do follow up. And okay, while we are waiting for other questions, may I ask, actually, does IME provide any scholarships?
Oh yeah, it does. So I think I saw a question actually for the link. So let me just share my screen first before I... Okay. Are you seeing the link for the QR code?
Yep.
Yep. So A-STAR has many different scholarship schemes available. I think it's best if you check online on the website. There is A-STAR Graduate Academy, and under that there's various scholarships all the way even from a bachelor's degree to your master's to PhD and even a postdoc fellowship. So yeah, so please check it out.
I see. So you mentioned about there are a lot of opportunities in IME. So is there a growing demand for PhD students as well?
Yeah, definitely. I think it's in a huge demand for PhD students. We're always very happy and excited to work with new PhD graduates, and they always have very interesting ideas. In fact, I think the whole industry right now is getting more and more innovative. A lot of this innovation requires a huge amount of people to work together, large teams to work together to focus on all these different aspects, because it's more complicated than just a single device. We look at, even on the processing level, you need to understand on the chemistry, even creating the plasma and etching, that's applied physics, and then material science to understand on the material properties, whether you're getting that high coefficients or not. So all kinds of talent actually is really needed in if you have a PhD degree, and the semiconductor industry is definitely, and IME is more than happy to work with new PhDs. Yeah.
I see. And Chongshen wants to know more about the challenges working in your team or IME in general, and what do IME look for when they are like interviewing employees, interviewing candidates?
Oh, okay, sure. So the first part, could you repeat the first part of the question?
Are the challenges working in your team or in IME in general?
Oh, okay. Yeah, I think maybe the main challenge initially is that, which may also be a good thing. So IME is somewhat of a bridge in between academia and industry. So we do both fundamental, pretty low TRL research all the way up to the higher TRL research, meaning that we cover a huge range of research. So initially when you enter, you may be exposed to also these industry projects, which is a good place to learn a bit about how the industry works in terms of R&D, which is very different if you did your PhD in a university. So that may be something new for everyone. And then at the same time, I think for IME, one thing is to learn how to, you need, I think this applies everywhere. You need to have your own clear goal and vision for your own career, what you really want for yourself, and also have that aligned to the organization so that it's, both everyone is benefiting from it. It's a win-win situation. So this is something that I think would be beneficial wherever you go. In terms of, so the second part is on the...
Any tips for the interview or what you are looking for?
Oh yeah, sure.
On potential employees.
Yeah, so I think we're looking, firstly, definitely there needs to be some technical background in this area, so that it covers that basis, and then from there it can be built upon, because we don't expect everyone to have the exact kind of needs that we're looking for. And then secondly, it's really how you think, your logical thinking, whether you go through like this process and you really understand the details. So the devil always lies in all the details. And then also, I think finally it's on passion. Passion for this whole research and this whole industry. That is really important, because without that, I think for any job that you find, it would be hard to, make a success for yourself. Yeah.
Understand. Thank you, Lennon. And I think that's all the questions as of now. For those who have other questions for Lennon, please feel free to connect with him on their LinkedIn page. So once again, thank you for your time, Lennon. And here comes to an end of our event today. So before we leave, can we have a group photo with the speakers? Since Jen just now have mentioned she is going to have the class, so we will have Lennon and Chi Ping to have the group photo with us. So Chi Ping. Okay, Daphne, are you ready?
Yes, 1, 2, 3. One more. Okay, thank you.
Thank you. And thank you for all the participation from our thank you for attending today's event. And for those who want to rewatch today's section, you can go to our website electronicsday.com.sg later. We will upload the event there. And we have also uploaded our previous events, including the virtual launch and the career talk held in last week onto our website. So please feel free to check it out. So thanks again for coming today. We will see you later. Thank you.